Hello SGD, Sacred Geometry Decoded. In some recent drawing exercises, so for instance I drew a 24 pointed star. You can get the Maltese cross, but also the Templar cross, and just most recent drawing one was creating a 40 pointed star. So it really just began with a pentagram, and then a decagram, a 10 pointed star, then a 20 pointed star, and eventually you divide the circle up into 40. So 9 degrees becomes the smallest division you can make, and with the 24 pointed star, 15 degrees, because if you divide it becomes 7.5 degrees. If you divide 9 you get 4.5. So the idea is how to build up towards a 360 division to create a compass. So in the last one so basically you start with this one and you get a 15 degrees, okay, but here you also get 9 and 18. So essentially what happens is I was going to take this construction sort of and base it around this one, and then you get a 3 degree division. So combining these two, you can divide the circle up into 120 or 3 degrees, and then you need the next step is to create the 360 degrees, which sort of involves trisecting the angle. But before we go there, so I was thinking, well, there's actually a simpler way to do it, and it actually begins with the same construction that you begin with the pentagram, but also relate to the microcosm and macrocosm, the 6/5, which you can also use to find the corner angle of the Great Pyramid. But so let's do a Pentadecagon, which is a 15 pointed star, and from a 15 pointed star we can get 30, then we can get 60, and then we get 120. So with a single construction, so you'll avoid a lot of steps, and with one construction you'll get 3 degree separation, 120 points. But so we'll begin with the method that I use to get this is the same. It involves drawing a pentagon, or the same method for constructing a pentagon or a pentagram, but then you add the hexagon to it, and then we can get a Pentadecagon. So essentially we're going to be drawing a 15 pointed star. Now once you have a 15 pointed star, then you can reverse engineer a pentagram, because you just skip you go to the third point, so 15 divided by 3 gives you 5. Now I'll do all the construction lines in red, and then I'll shift colors, but I'm going to begin with so it's going to begin with a vesica, but I need, rather than get a long ruler, and begin with a construction line. I'm going to place it roughly in the center of the page. And how large should it need to be? This should be okay. Now, begin with a vesica, a little bit larger I think. Okay. I only need one side of a vesica to be on the construction line, and I want to use as much of this line as possible. So I'm going to begin over here on the edge, and turn on the light, make sure we get a better view. Okay, now I want to be as accurate as I can, so I might be sticking my head in the front of the camera every once in a while. Okay, now we have a vesica. Next step is to use these 2 points. So we've got the horizontal, now we want the vertical. And put your point where you're going to start, and you can adjust the ruler a bit better. And now we find the center of that. Now I'll be drawing the full circles here, but again you only sort of need a few points, but I just like, I'm going to do them in red as well, so that the construction lines sort of stay underneath, and you can sort of see where it emerged from. Okay, now with that because I want to keep this compass without changing, I'm going to use another one. But this is the only point that you actually have to change your compass settings. In sort of a strict rules of compass and straight edge, every time you take it off it collapses, but what we have now is if half the radius, okay, we're going to define that as 1, therefore this has to be 2. So I'm just going to highlight. So we have 3 points, we have an equilateral triangle, 1, 2, therefore that has to be the square root of 5. Put your compass point here, adjust to the square root of 5. Square root of 5 plus 1 equals 2 phi. So there's another cool feature. It's actually quite a big, and that's why I like this construction, because this is actually a great template for so many other features. I'll do a separate video on drawing the full template and all the things that you can get from there. So if this is 1, then this is the square root of 5, which means this is square root of 5 plus 1, which is pi over 2. Now, how are we going to, so if we put the compass point right on the edge here, and that's why I didn't want to change this compass setting. Okay, so one thing that we've done is we've bisected. That's 2 phi. We've bisected that, and anyway, all the points are there for the pentagram. I showed that in the last drawing. I put the links there in the description. But what is, now I can take this one away. What we have now is with this point, and this one is we have the top of a pentagon. All the points for a pentagram or pentagon are here as well. You actually have to draw the pentagram to find the other, but what we have there, and so I'll just fill that in. So that's the top section. You have a large part of a pentagon, and I've tested these on Geogebra, and so the angles are, again, if you mathematically, geometrically speaking, absolutely perfect. Of course, with the drawing, but what you have is that this angle is exactly 108 degrees, and all triangles are 180 degrees, so these two, it's an isosceles triangle, so that has to be 36 degrees, and this has to be 36 degrees. Hopefully that's showing up. Now, original compass setting, so what happens is also that you have each side of this pentagon. Now again, I could just just extend it through, but we're going to draw a Pentadecagon, a 15-pointed star. So they're all equal. Now I already have one circle centered on this corner, so I need to do another circle. Now I'll put the link to the Microcosm, Macrocosm video, because that's how a hexagon and a pentagon of equal edge length emerge. Okay, but now with this circle and this circle here, I have a vesica again, and I could draw the whole seed of life and create the vesica, but that's not necessary. All I need to do is create one part of the hexagon. And so, for instance, this point, and this point creates an equilateral triangle. Now I'll find that. Try to get that as neat as I can. Okay. Okay, so one circle, that's a vesica. This circle and this circle is a vesica. Between this here and here we have a trinity. So in other words, I have an equilateral triangle here. 1, 2, 3, create an equilateral triangle, and I also have an equilateral triangle 1, 2, and 3. So I have the most part of a hexagon. I could carry it around, but the only line I really need is here to here. Okay, so equilateral triangle, Therefore, this angle has to be 120 degrees. We have a line there, and so it has to be 180. So 36 plus 120 is 156, which means that this angle has to be and is precisely 24 degrees. 360 degrees divided by 15 pointed star equals 24 degrees. So we have the hard angle. I actually should have extended that when I drew it, but now so when I first drew this I should have extended it out a portion. And get my head in the way. Also want to extend this construction line. Okay, 24 degrees, that's the central, the core or the hard angle of the Pentadecagon. It's also called a Pentadecagon, anyway, 15 points. Now, that's our core angle, so now I'm going to change. We have all our red lines, which are construction lines. I need to find that. Okay, I'm going to create this circle, make it a little bit larger, and I've shifted to a pencil, so hopefully that differentiate the colour a little bit from the construction lines underneath. And this is the circle I'm going to use to create the 15 pointed star. So I'm going to really darken that. Now I'm just going to reset the camera. If I make the files too large, the computer doesn't like it. Okay, now while I restarted it, I should have originally kept that construction line, the first one, extended it out a little bit, and when I drew this portion I should have again extended that out originally. I lined up the ruler, but there's an ever so slight difference. So this geometry is 24 degrees. Now the issue is here, when you adjust your rule, you want to, like, it's really important to get very accurate with variable. You know, like I'd need to stick my head right up against the paper to get the points in there. And so while I had the camera turned off, I tested it, because originally I went around and I was a little bit short. For instance, the point of this line when I stuck it in was like just below the line. You know, from where with my head back it looks like it's on. When you look up close, it's actually just below. And so I've ran it out while I had the camera away, and it will work. But if it doesn't work the first time, it's first you need to be just accurate as you can, and even lining up these, you know, it's you've got to be spot on, sort of right in there in the middle. But anyway, what I'm saying is, once you've set your compass to that point, now it's just a matter of running the circles. So rather than draw the whole circles around, I'm just going to mark it out, and all things going well, it should come right back and perfectly. Again, it will, and it does, divide the circle up perfectly into 15 points. Whether you're accurate enough and the point of the pencils is neat enough and the paper's not sliding, where you put your point. So even like when you put your point in the paper, if you stick it in too much, it creates a larger hole and it can wobble around on the inside of the hole. So that's and then you multiply that by 15 times, and this, sort of a fraction of a millimeter is going to so 15 times a fraction of a millimeter will end up being a couple of millimeters out. So it's Now I come back. Yeah, okay, so again, while I was off camera, I just tested it and went around. The first time I was just way off because I just, didn't look very closely there. Again, I should have extended these lines originally to begin with. So if you're doing the drawing, keep in mind, I lined up the ruler and extended them out, but that creates just, it's ever so small, but each little error will multiply upon itself and then it'll come out. So now we do have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've divided the circle up into 15 points. Now I'm going to go to blue. I wish I had a finer point to do this next part, so I just want to differentiate from the red construction lines in the back, and now it's just a matter of drawing that star. Now I could just okay, actually I will do that first. I'm going to go from point to point and create the polygon, the 15th. So Pentadecagon is the so that's like as in polygon, that's the shape. So like a hexagon is like in the beehive is the 6-sided shape. A hexagram is a 6-pointed star. Pentagon is the shape, and a pentagram is the star. That on the other side so it's not in shadow. I didn't take account of the thickness of a pen that time, so I don't know. So especially like with a ballpoint, even with a really fine point pencil, you have to get sort of used to doing it, make sure. But so yeah, just lining up the ruler, always add that little bit of distance for the thickness of the marker. So if again, like on a computer program, like a dot is just a point in space. It doesn't exist. A line is just it has no thickness to it. But when you're drawing, it does. And so to be as perfect, accurate as you can, you need to consider that. Okay, so now we have our 15-agon, and I won't take away the pencils just yet. Now, how to do the Pentadecagram, or the 15-pointed star. So like with the hexagon or hexagram, okay, that's 2 equilateral triangles. So you have to take the pencil away from the paper to do that symmetrically. Now a pentagon, because it's an odd number, or a pentagram I should say, I don't have to take the pencil away. I can do it all in one line. And so this Pentadecagram is like with the pentagon, it's one line. Now pick a random point, basically going to go to the opposite. So you want to get as close to the middle. You won't pass perfectly through the middle, but that's the first step, and then you can just sort of follow that around. And so I'm like drawing a 24 or a 12-pointed star. It's a little bit in the shadow. Okay, now I draw the line, I come to that point, and so I'm not taking away the pencil or the pen from the from the paper. And now it's just a matter of running it around. And so each time you sort of just want to go as close to the middle as you can, but now it's going to run around in a directional way. So the ruler is just going to be continually rotating in one direction, and so once you get that first one correct, it's just a matter of repeating it. I'm going to take it away just so I can get that point, but you get the point that, you know, technically you don't even have to take the pencil or pen away from the camera. Yep. Make sure you got the ruler firmly down. Let it slip up there because I'm doing in pen. I can't fix that. That little line there. So again, if you want to do these drawings, you want to be that little line doesn't matter. But you know, if you want to do it to, you know, keep it and have it sort of up, yeah, that's one little mistake like that at the end can sort of ruin something if you're trying to be super precise and, you know, for something for display. Again. And this is the final line. You come back to the origin, and now we have a Pentadecagon and a Pentadecagram, and you have, especially on the inside, so if you sort of want to colour alternatively in and out, it creates sort of nice, you know, you can be as creative as you want with the decoration colouring in. I suppose because I made these two mistakes here, well, one way would be just to colour those sections in, and then you can't see that mistake. And hopefully you do it in a that you can cover that up, but that's one way to do it now. But the point is, now we've divided the circle into 15, so I'm going to tilt it a little bit, and so let's just say that this is 360 degrees or 0 degrees. That's going to be 24, 48, 72. Okay, now because I have 72, the third one is set. I can now just skip the next one. So I skip 2 again, and this would be 144. I skip 2 again, that would be 216. Skip 2 again, and that would be 288. So 1, 2, 3, 4, 5. You also can now draw a pentagon or a pentagram in there, overlay it just to, you know, maybe as a there's more of these sort of star patterns you do on top of one another, really will create like a nice looking pattern that builds up. Yes, so we have 72, 90, would be 24 would be 96, 120, 168, 24 hours a day, 7 days a week. That's 168 hours a week. 176 would be 192. That's 24. 240. 264. Okay, that's a nice one because there's so 33, 66, 132, 264. And next one would be 528, so as in 5,280 feet per mile. So that's a nice interesting number as well. 292, 308, 312 degrees, and 336. Okay, so now you've divided it into 15. Now each one of these is going to split, so this chevron here would go right through the middle there. So for instance, I'm going to start here, so where this point of a star is, if I go through the middle, it's that chevron's going to divide it up perfectly. Okay, so about 24, so 24 degrees, 48 degrees, so it has to be half, so that would be 36 degrees. Now if I was to follow that all the way, do that all the way around, now I have a series of points to create another pentadecagon, and I would create a 30 pointed star. By using that same rule again, finding one of the points, going through the center, I get a 60 pointed star. If I was to repeat that again, I would get a 120 pointed star. Now that is a bit of work, but compared to sort of, you know, using a 24 pointed star to get the 15 degrees, and then using a 40 point division to get the, you know, down to the 9, it will be a simpler construction. It's still going to be a lot of work, a lot of lines to go in it, so I'm not going to carry on. But if you saw the previous, because this star bisects itself, and then between each halfway point I go from 15 to 30, then I repeat that, I get 60, then I repeat that, I get 120. So ultimately I'd come down to 3 degrees. The next one would be a pentagon, but just as an alternate. So that's the Pentadecagon, or the 15agon, or 15agram, where you have a 15 pointed star or a 15 sided poly around the outside. So actually this one would be, if I was drawing a compass, I would do it with this one. I'd use probably a bigger sheet of paper to start off with as well, but geometrically perfect. It originates from the 24 pointed star originates from the hexagon. This one originates from the pentagon, and again I'll link that in the description. The macro, so the construction lines underneath begin with a pentagon, and then we created a hexagon. I didn't go all the way through because it's not necessary to do the whole thing, but it's the same original sort of construction concept, but giving us a 15-sided polygon. And yeah, and you get the angles of the numbers as well are nice. I never really thought so. For instance, 264 and 168, they're not Pythagorean harmonics on that chart, but they're they're very closely related now, especially 264 is 33 times 2, 66 times 2, 132 times 2, 264, and then you get 528, then you get 1056, which for instance the ancient Longfoot being 1.056 feet. So especially in metrology, but also in various other traditions as well, the numbers of degrees, of numbers of time, the numbers of weights and measures, and also astronomical proportions are really just loaded in this geometry, and it's that concept of 360 degrees as well, which is quite ancient. Okay, that'll be about it for now. Rather than go through all the continue the drawing out, again it's just pick a point, the trough or the chevron opposite is going to bisect it. You just repeat that all the way around. Now you have another 15 points. Do that same pattern of drawing the star. You get 60 points. Then repeat that again through. Just pick a random point and just follow it all the way through. And if you want to do a really nice complex geometrical drawing, be really careful, because again, if you let your ruler slide a little bit, that's why I like to do it in pencil. And then anyway, but there you go. Have a good one.